5, 3 plus 2 is 5, 5 plus 0 is 5. The exponents always add up to n. Okay? So we're starting to see some patterns. The exponent, or the power, of 1/6 always equals little x. And then we've seen that the exponent, or exponents, of 1/6 and 5/6 add up to n, where n was the number of trials. So here the number of trials is 5 because we're rolling 5 die. Okay. So this is these are kind of two pieces of the pattern to identify that this is a binomial distribution. There's a little bit more math involved, but there's also a pattern with these integers up front. If you've ever heard of Pascal's triangle, or you've done, if you think back to your algebra classes when you did FOIL, so you had like x plus y squared, and you wrote that out as x plus y times x plus y, so you'd have like 1x squared, 2xy, 1y squared. There's a pattern to these integers, and all of that stuff is kind of related. Okay, so I'll just introduce the formula to you. But we won't really use the formula. It's built into the calculator. So if you want to find any of these probabilities, probability that big X equals little x, so all that you would change here is your little x. There's going to be some number. And for any particular probability, here's the formula. And it looks kind of weird, but we'll introduce the pieces. So we've talked about several of these already. So little n, that's your number of trials. Little x, well, so far we've thought of that as the value of the random variable. But now, in this specific case, what we're kind of doing is we're counting successes. How many outcomes of interest do we have? So like in this example, we're counting the number of 5s we roll, so we can think of the 5 as a success. So when we look at the probability distribution, we're essentially counting how many successes we had. We had 3 5s, we had 3 successes. So in general, we can think about little x as the number of successes. Looking at the formula, we'll skip this parentheses thing for right now. We see that there's a p to the power of little x and a 1 minus p to the power of n minus x. So the last thing to introduce is p. So in general, what this is this is the probability of success, whatever you've defined success to be in your problem. So what that means is 1 minus p, well, that's the complement. So this is going to be the probability of failure. And again, I guess I can put these in quotes because they don't have to be a good thing or a bad thing. Okay. So if we want to find any particular probability, we take this weird parentheses thing, which I'll talk about that in a second, times the probability of success raised to the power of little x, and we sort of have that. That's what this pattern is. In this dice example, n was 5, p would be 1/6, the probability of seeing a 5. And then these are all of your little x's. So like in this first case, we have p to the power of x. 1 over 6 to the 0th power. So that's the p to the x, and then we have 1 minus p to the power of n minus x. So again, if you add these together, x plus n minus x, the x's go away and you're left with n, the number of trials. So your exponents add up to n. If p is 1/6, then 1 minus p, or in this case the probability of rolling something that's not a 5, is 5/6. And its power is n minus x, 5 minus 0. Okay? So that's why we went back and rewrote this with the 1/6 and the 5/6 and the exponents. Now the last thing to talk about is, well, where do these numbers out front come from, the integers? What is this parentheses thing? So I'll show you what it is, but you don't have to worry too much about it. It's built into the calculator. So when you see this, the first thing is that this is not a fraction. These things are not being divided. This is equivalent to the following equation. N factorial, so maybe you've never seen that before. The exclamation point is a mathematical operator called the factorial, over x factorial times n minus x factorial. Okay? So the point of this function, this formula, is that this tells you the number of, I guess I'll call it combinations for right now. Maybe more generally, I don't know. Maybe more clearly, I could say this is going to tell you the number of ways of having little x successes in trials. Okay. So what I'll do is I guess I'll first tell you what a factorial is, and then we'll go through some of the applications of this to that dice problem, just so you can see how the results fit in to the probability distribution. So in general, for any factorial, say that we have the value of 4 factorial. What that means is you're going to start at 4 and you're going to multiply together every integer below 4 with 4. So we do 4 times 3 times 2 times 1, so we get 12 times 2 is 24. Okay, so you're just multiplying every number below, and including whatever the factorial is. So for example, what if we just, for some reason, didn't know how many ways that we could see 0 5s in 5 rolls? What that weird parentheses thing is doing is it's giving us this integer out front. So let's see what happens. What we're going to find is 5, 0. And the way that you read this, if you wanted to read this, you'd say 5 choose 0. And again, basically what we're saying is in 5 trials, how many ways can you choose 0 successes out of those 5? So if we fill in the pieces, we're going to have 5 factorial over 0 factorial, which that's just defined to be 1, times 5 minus 0 factorial. So we have 5 times 4 times 3 times 2 times 1. 0 factorial is 1. 5 minus 0 is 5, so we have another 5 factorial. And we see that these cancel out. The 5s cancel, 4s, 3s, 2s, and 1s. So we're just left with 1. So what this is saying is, how many ways can you have 0 successes and 5 trials? And the answer is, there's 1 way. So let's do this for how we began this problem. What if we had 5 trials and we wanted 3 successes? I told you the answer was 10, so let's verify that. So we have 5 factorial over 3 factorial times 5 minus 3 factorial. So what we end up with is 5 times 4 times 3 times 2 times 1. That's the numerator. 3 factorial And then 5 minus 3 is 2, so 2 factorial. And again, we can see that we can cancel some stuff out. So the 3 times 2 times 1 cancels out. The 2 and the 4 cancels out, and that becomes a 2. So we were left with 10. So there are 10 ways to have 3 successes and 5 trials. Okay. Yeah, I won't write them out for you. You can think about it, and you can figure out all 10 if you want, but I won't write it out. So the point of all of this is, say that I ask you to fill out this probability distribution. If certain assumptions are met, which we briefly defined a minute ago, and I'll go back through, then we can say that this random variable, big X, follows a binomial distribution. And when we know it follows a binomial distribution, we don't have to think about all the different combinations and the probabilities. We can just take a shortcut. This single formula will find the probabilities of interest. When you have a binomial random variable, it's also easy to find the mean of its probability distribution. You just take n times p, your number of trials times the probability of success. This symbol, it's kind of like a weird O with a hat on top, is sigma, and this is the variance, because it's sigma squared. So if you want the variance of this distribution, you take n times p times 1 minus p. Often we don't want the variance, we want the standard deviation. So that's represented by just a single sigma, no exponent. And if you remember from quite a few weeks ago, that's the square root of variance. So the square root of n times p times 1 minus p. So the square root of variance is standard deviation. Okay. So let's do some calculations. So we've done some of this by hand, and so we can multiply this out by hand, and then we'll see what this calculator function would do. So on the next page, we'll swing back to this. There's if you follow these instructions, which we'll go through, then you can have the calculator compute these probabilities for you. And then we'll talk again about the assumptions of what makes a random variable follow the binomial distribution. So let's multiply this out. So we can write it out in some pieces. 10 times 1/6 to the third. So that's going to be 1 over 216 times 5/6 squared is 25 over 36. So for the numerator, we'll have 10 times 25, which is 250, over 216 times 36, 7776. So we should get 0.0322. So if you compute this out, you're going to get a lot of decimal places in some instances. So try to go to at least 4 spots, 4 decimal places. That's usually sufficient to get you close enough. So we would round that to 0.0322. Okay. Well, what if we didn't want to do this? We want the calculator to do it? Well, pretty simple. There's this built-in function called binomial PDF. So that stands for probability density function, just in case you wanted to know. And it requires 3 inputs. So again, n is the number of trials. P is the probability of success. And we're going to have to enter this as a decimal, meaning as a proportion. So you can type in fractions or you can just type in decimals. Has to be between 0 and 1. And then lastly we have little x, so that's the number of successes we want. Okay. So the instructions, you'll press the second button, the vars button, and then we'll find this. So I will walk you through that. Okay. And this is still what we're interested in. So if we wanted to, we could use the binomial PDF here. So what we have to tell it is that we have 5 trials. The first thing it wants is n. Next it wants p, which is 1 divided by 6. And lastly, the x, the number of successes. So here we want 3. So if we want to use that function, how do we get there? So the first thing you press is the second button, this yellow button. Next you're going to press vars. So what's happening here is, if you look at your calculator, above most of the buttons there are letters in yellow and there are letters in green. So if you want to access the stuff in yellow, you have to press the second button first. If you want to access the stuff in green, you have to press the alpha button first. So what we're going for here is we want this DISTR menu. So that stands for distributions. It's probability distributions. So we've pressed the second button, we press vars, and it should bring you to a menu that says distributions. And you'll see a lot of distributions. So in front of the 7 there's a down arrow, so that means there are more if you press the down arrow. It goes all the way down to letter E on the TI-83.